Tatyana Nikolova is from Intel, and she is specializing in RDMA drivers. She's been contributing member to OFA, we all know, since 2012, and she's also been the co-chair for Fsdp work group. She has a lot of experience driving Intel's participation in OFA logo event, and hence her participation in the next Bird of Feather session after the presentation now. She's been working hard to make sure that the current Intel Ethernet RDMA products meet the logo requirements set by OFA. She holds BS bachelor's degree in computer science from the University of Washington and a master's degree from the University of Texas, Austin, both in the field of computer science. So Tatyana, welcome, and the stage is yours.
Hello, thank you, Divya, very much for the introduction. This presentation is a joint effort between Doug Ledford and me. So he is going to cover the deep dive into the Fsdp section later on. I'm going to begin with the introduction. Is there a way to move to the next slide? Should I? Okay, thank you. I guess I can just say next slide. So, Fsdp, what is Fsdp? Fsdp is a hardware matrix test cluster. It includes hardware from all RDMA integrated hardware vendors. Broadcom, Mellanox, Intel, Cornelis, Marvell, Chelsea, etc. Adapters of different hardware types are available in the cluster. The hardware types are InfiniBand, OmniPath, Rocky, iWarp, etc. Our current requirement is that each vendor who would like to participate in Fsdp should send us at least 2 adapters of the same make and model. So these adapters are installed in servers, part of the Fabric software development platform. This is what Fsdp stands for. The OFA members are the Fsdp users. They can run apps, develop software, or work on software fixes using the Fsdp servers with the desired RDMA adapters installed on them. All this is included in the OFA membership. Fsdp also will also include hardware related to RDMA technologies, like NVMe for NVMe over Fabrics testing, NVDIMM for remote persistent memory over RDMA testing, GPUs for peer-to-peer DMA and GPU direct testing. Next slide, please. In addition, just like Intel Upstream Kernel zero-day testing and Google Syscaller testing service, Fsdp is going to run a continuous integration testing service for upstream RDMA kernel and user space software. This service is going to ensure that code actually runs on the target hardware. And Fsdp is going to utilize the upstream ecosystem to advance testing tools and maintain high code quality. The Fsdp, next slide, please. Could you go one slide forward, because I think I kind of shifted them when I was getting ready for the presentation. So there is this upstream kernel community rule. If you submit a patch and it breaks something else, you're responsible for fixing your patch. The Fsdp continuous integration testing is going to catch the breakage early, as patches are first accepted in the kernel RC. And this is going to allow for the fix to come sooner, before the bug has propagated down to all distros. Could you go to the previous slide? Here is a summary of the FSDP flexible usage model and intended audience. Linux upstream maintainers are going to benefit from centralized testing of multiple hardware vendors' products and bug tracking in RDMA upstream software patches. Bugs are going to be caught early by the CI service. Hardware vendors and distros are going to benefit from the CI service in a similar manner. On-demand testing or development is another service provided by FSDP. Distros can test their new releases on a multi-vendor hardware setup. Integrated software vendors can test their apps and middleware on a multi-vendor hardware setup. And my last point here is has to do with our birds of feather session coming next. The possibility for creating a logo program, which could further help sustain high software quality, advanced testing tools, and also enforce industry interoperability standards. Okay, thank you. I think that's my portion of the presentation. If you go forward, yeah, this FSDP deep dive is going to be presented by Doug Ledford.
Hi, everybody. I'm Doug Ledford. I'm currently chair of the OFA, as well as I've been working at Red Hat for about 22 years now. I spent a large portion of that time at Red Hat as the preliminary RDMA person inside Red Hat. As a matter of fact, I'm still the subject matter expert for the RDMA stack. So I'm going to go ahead and jump in. Next slide, please. So let's talk a little bit about the FSDP structure and what software we're using to get this thing up and running. So there's a project that used to be a Red Hat project. It isn't any longer. It's been moved outside Red Hat, called Beaker, and the web address is there. And Beaker is essentially a bare machine lab controller. It allows us to provision machines from bare metal up to a fully installed operating system. And the general time to install is only about 10 minutes. So it gets things done pretty quick. Your machine goes from not doing anything to ready to go in 10 minutes. And so Beaker, once it gets a machine installed, also installs a test harness, and is capable of running automated tests, whichever test you want to specify. Red Hat's been using this as a basis for their own CKI project, and I don't know if you guys have heard about it. That's our continuous kernel integration project. It's a CI project designed around the upstream kernel and around various source trees. Obviously, we do a lot of that internally, but this the FSDP project is intended to do this specifically upstream in the visibility and space of the upstream environment. So, for example, the CKI runs that we are going to do with the FSDP will end up sending email results directly to Linux RDMA mailing list. There's not going to be any middleman. It's going to go straight there. And a few of these design issues about the FSDP have changed a little bit. Like here where it says that the build server with long-lived NFS mountable shares. It turns out that's going to be a little bit harder to do. I mean, that's what we did internally at Red Hat and worked great. But on the FSDP that we're doing, because we have people from different companies allowed to have accounts and log in, turns out we have to be a little bit more strict about account control and privacy than we did have to be on just Red Hat's internal stuff. So we aren't using NFS mountable shares only because if we did, it requires the machines have user accounts and Kerberos identities and Kerberos tickets for the hosts and everything else. So instead, we're probably going to end up using a download web area where you can get to your files off of the server via either Secure Shell FS or HTTP. But we have been getting this built. It is up and running at this point, at least running to a point. The machines are installed. We boot the machines up. We can provision the machines. We're now at the point where we're actually starting to tweak the installations on each machine so that it comes set up and ready to be used versus like a bare install that doesn't know you need, the RDMA packages or anything else. So we're working on that at this point. Next slide, please. So we've got a bunch of Git repos we use to manage the cluster. The most important one for people on this call is probably the Fsdp docs. This is where we're keeping all of the information about how we're setting the Fsdp cluster up, what its structure is, what you have to do in order to be able to utilize it. There's even the account request form inside of the Fsdp docs. And the other three repos all serve specific purposes, but they're in various stages of completion at this point in time. The Fsdp setup repo is where we're keeping the beaker configuration for the various machines, as well as where we're keeping any RDMA setup scripts that will be run on the machines during the post install to get them all set up and ready to use. Fsdp build is where we're planning on putting in container definitions. For those container definitions, we have to provide. We don't actually have to provide all of them, which is nice. We can use upstream container definitions where they're appropriate and available. And then the big one that we haven't really started filling out yet, but is the one that's going to end up being the big granddaddy of them all in the end, is the Fsdp tests. And the point of that repo is it's going to be all of the various tests that we can run on the Fsdp cluster in an automated fashion. And they're going to be smaller unit tests that are split up and will test specific features or functionality, not large overall tests, because the way the test harness in Beaker works is you can actually create an XML file and specify multiple of these smaller tests in it, and they'll run one after the other. So there's no need to make large tests. What we do then instead is just make smaller tests and let you put your tests into the XML file. And then that way you can build up whatever sort of test, overall test that you want. And then right now the Fsdp is a bare metal cluster. We talk about container definitions, but what we're talking about there is container definitions for the build machine. So there's a build machine available for people to use. You log into the build machine, and then you can build packages to test on the cluster. So let's say, for instance, that you want to be able to test a package that you're trying to get it backported to the latest version of SLES. Well, then the idea here is you would actually provision a machine with the latest version of SLES. Then you would go in to the build machine, and whatever package or whatever software it is you're wanting to test, you would build that package against the latest version of SLES. And then you would have a package ready to be installed on your machine that's checked out, and then you can do your tests. Well, we've only got a limited amount of resources, and we've got one builder. So what we are doing is we're using different containers on that one builder machine so that you can have the right build environment for whatever build it is you need to do with, RHEL, Fedora, SLES. We're planning on adding Ubuntu and some other stuff as well, but that's all going to take time. So the containers that we have right now are just build environment containers. They are not containerized machines. So the last point on this slide, where it says we might add containerized infrastructure, what it's referring to there is actually running containers on the test machines so that we can test things like proper containment of the actual containerized devices. This gives a way of testing the upstream kernel and making sure that it doesn't leak information from one container to another, or from a container into the main OS or something like that.
Hey,
So
Doug, there is a question here on chat. if I may bring it up. Is
Sure.
there value in testing RDMA for the next branch or versus wait for the inclusion in, I guess, x.y RCN means, I guess, the upstream they're referring to? Donna, please feel free to ask the question.
Yeah, so yes, absolutely. So I kind of posited something to Jason Gunthorpe about this, and I've kind of got an idea in my head that maybe we could turn this into a little bit of a research project. And that is that, you know, at the upstream RDMA kernel stack could, if we choose to, make it a requirement that, you know, before anything goes from a private Fornext branch, such as Fornext, JGT Fornext, or my own Fornext, before it goes from that into the official Fornext, it must pass, you know, an appropriate test set on the Fsdp. And if we put that requirement in place and run a couple kernel development cycles with it, I was curious to see how that might affect the number of RC patches that go in during the RC phase of the kernel development cycle. I figured we could go back and run some numbers of how many RC patches go in on a regular basis per kernel for, say, the last 5-10 kernel releases, and then turn around and compare that to 2 or 3 runs where you have to have a passing Fsdp test before your code goes into Fornext, and see if that has a material impact on the 4 RCs during the RC cycle. I suspect it could, and if it did, it would provide a nice data point for the usefulness of CI type infrastructure and increasing quality in your initial software drops. Does that answer your question, Don?
Yeah, thanks, Doug.
Okay, next slide, please.
Yeah, I should say I like the idea you're doing a research to prove where's a good point versus picking one and just going. So I like that even better.
Thanks. Okay, so what we're talking about with the upstream CI service, and this is something I want to point out. I know Tatyana touched on this for a second, but I kind of want to harp on it a little bit. This is only the 3rd upstream pro bono service being offered by somebody. Intel offers the 0-day service. They don't charge anybody for that, and they let you sign up for it. Google runs Syscaller, and like I said, they don't charge any of the upstream people, and they don't even have you sign up for it. They just run it anyway. So this is the 3rd such type of you know, pro bono upstream service being provided by any organization. And this is something that I think the OFA is rightfully proud of. You know, we're putting in our work and our effort to try and help the upstream kernel be a more reliable, more robust kernel. And I think that, you know, in and of itself, by itself, warrants recognition. But so the way we're planning on doing this is very similar to the other CKI stuff inside Red Hat. Actually, we're going to be using a lot of their infrastructure. But there's a daemon that patrols for upstream changes to various Git trees. Any particular upstream maintainer or an upstream developer is welcome to submit a request to the OFA to have their upstream tree monitored. A lot of them, obviously, we're going to start monitoring and picking up without even needing a request because we know what the trees are, but there might be others. And so when it sees the changes, it compiles a new kernel. And then for the purpose of the CKI stuff, we're going to end up using the latest Fedora release to test it on. And that's only because Fedora, out of all of the various OSs, distros out there, is the one that most closely follows upstream anyway. Usually new upstream user space packages land in Fedora first, and Fedora actually follows the upstream kernels already. And so there's less float differential between Fedora and anything else, you know, the upstream kernel and stuff. So it's most likely to work and not have extraneous problems that we really don't want to go sorting through, because none of us really want to run CKI on an upstream kernel and then have failures that are the result of glibc not being updated to a late enough version to work with the latest upstream kernel. So that's the reason for picking Fedora for that. you know, obviously I have a little bit of bias being a Red Hat employee, but I don't think there's any inaccuracy to the statement that Fedora is the one that follows Upstream the closest. And it does make it sometimes a little bit harder to use because it will break more often than other stuff. So I'm not surprised, you know, that not everybody does that. But we'll be installing the CKI runner. It'll monitor the upstream trees. And as changes come in and get committed to the branches we're monitoring, it'll run the automated test plans. We've got some ideas here to maybe even make the automated test plans non-static so that the code that monitors the upstream tree might be able to pick out based upon what commits there are between the baseline tree and this current patch set, what tests might be appropriate. You know, let's say, for instance, all of the changes are constrained entirely to the MLX5 driver. Well, there's no sense running in and testing Chelsea OI warp on that. It's just a waste of time. And so picking and choosing what tests to run based upon what code has changed, that does not currently happen with the CKI subsystem, but it is something that I've been talking with the CKI developers inside Red Hat, and that's absolutely on the menu for an upcoming release and future changes. And we want to do the exact same thing here upstream. So we'll probably end up working with them actually to help make that happen. Otherwise, it's entirely possible that, you know, the amount of CKI testing that needs to be done could completely overwhelm the FSDP cluster. So getting our testing down to a reasonable amount of testing on any given change is something that will be important. But when it's all said and done, after it runs the test, the results will be reported to an upstream mailing list. You know, mostly likely Linux RDMA, but it could possibly be someplace else. For example, if we're doing tests on the libfabric library, then it doesn't need to go to Linux RDMA because libfabric development is done on an OFA mailing list. Next slide, please. So we also the FSDP supports what we call the on-demand program. Really, what that boils down to is manual. With the Beaker, you can do an automated test run where you feed an XML file into the scheduler. The scheduler picks out the machines based upon some parameters you put into the XML file. And then once the machines have been checked out and provisioned, it runs your tests. The on-demand stuff is you log into the Beaker web interface, you go find a machine that has the hardware you want, and then you click a button, the label on the button says take. And at that point, you've taken the machine, it belongs to you, you get to provision it with whatever you want. And once it's provisioned, it comes up ready for secure shell access. Then you can upload your software, you can build software in the builder if you need, and then you turn around and you run your tests that you need to run. And it's all manual, so you just log in and do the tests via secure shell. This, by the way,
Doug, is there a guidance or requirement for the test duration, like how long this needs to run?
You know, there is some guidance on this, but it's not hard, fast guidance in the scheme of like, you know, it has to be 1 hour or 3 hours or 5 hours. More what we have is the FSDP working group, which is chaired by Tatyana and I, have the responsibility of monitoring the usage of the FSDP cluster. And so as long as other people can get in and use machines, we don't care. You can use it for as long as you need. It's when the machines start becoming contended and where, you know, automated test runs are backing up in the scheduler because somebody's had a machine checked out too long and stuff like that. And then we're going to come and ask you to please log off the machines and let some of the automated tests get run through.
Okay.
In future generations of the FSDP, because right now, you know, we're starting small. We're walking before we run. In future iterations of the FSDP, it is entirely possible that we may have enough machines that we take some portion of those machines and dedicate them solely to CKI so that they aren't available for manual usage, and we don't have to worry about people checking them out for too long and keeping them hogged and backing things up. But we're not to that point yet. So So like I said, going back to this, the manual testing, you go in, you do what you need to do. When you're done, you just simply release the machine and the Beaker web interface, and it goes back into the pool and is used in the future by other automated tests. Next slide, please. And as we're going to have a BOF immediately after this, and as I suspect that this is going to be something that a lot of the different hardware vendors and a number of the different customers will probably have an opinion on, the FSDP could be used for a logo program. And we had two types of logos in mind, a distro logo or a hardware vendor logo. So kind of, you know, it sounds like what it sounds like. You know, a hardware vendor logo will logo a particular piece of hardware runs with this set of, you know, whatever, and maybe with a specific software set. And then a distro could turn around and say, oh, well, our, you know, maybe RHEL 8.3 supports, you know, this hardware and these configurations or whatever. And so this logo program is still up in the air. And we really are trying to get feedback from the community as to whether or not they see value in a logo program. And that's something, like I said, that we're going to go into in the BOF that's supposed to start in 6 minutes. So not very, very far away at all. So I'm not going to spend a lot of time on this. Next slide, please. Okay, Tatyana, you want it back?
No, I'm good. Thank you.
There is one question that came in. How are you planning to manage the firmware? Dual port NICs, CAs, overall good idea. Looking forward to share some OpenSM test cases. That is Vladimir. If he wants to chime in here, please feel free.
Okay, sure. So as far as the firmware is concerned, what we generally are going to try and do on all of the NICs and CAs in the cluster is keep the firmware at the latest released level. But as long as you have the ability to upload the necessary tools, or the tools are included in the distro of your choice, if you want to get in and test your own hardware with a beta rev or alpha rev firmware against other people's hardware so that you can test for compatibility, feel free to go ahead. I would assume that what you're going to do is test your own firmware inside of your own shop whenever you're just testing, you know, between your own devices. The only thing we ask is that when you're done doing your testing, drop it back to a released firmware version, because we don't want other people trying to track down bugs that turn out to be beta or alpha firmware bugs. Next slide, please. So the membership levels at the OFA currently are based upon the bylaws, and the bylaws are in the process of being rewritten. They're almost done. We're kind of going through final review phases. It's going to the lawyers. The lawyers are kind of hacking at it a little bit, but for the most part, it survived the review by the lawyers. But the current membership levels are promoter, supporter, and adopter. And the new membership levels that we're going to be proposing are going to still have the promoter member level of the OFA, which is the highest level. It's the one where you get a seat on the OFA board. Then we're going to have voting members. A voting member is high enough that you can actually vote on things in working groups, which is going to be important in the FSDP, because if you want to participate in the FSDP, and let's say we do have a logo program, there will be votes about what constitutes a logo. And so if you want to have voting rights in that, you have to be at the voting level. Then there's the non-voting member, which is the lowest level. You still get access to the FSDP cluster, but you can't really vote on anything about the FSDP. And can't really, you know, you can use the FSDP, but you've got no say in anything. You're allowed to have access, but that's, you know, all you got there. Next slide. So if you want to participate, then like I said, that GitHub with the FSDP docs, that is where you want to go. It's got an FSDP account request form. Just to be clear, there was listed on the previous slide an individual membership. So if you are a bona fide Upstream developer, you're working on stuff, but you don't work for a company that does anything RDMA related. However, your upstream work has some relationship to RDMA. Then you can get an individual relationship or individual membership of the OFA and access to the FSDP. It doesn't cost you anything. We do limit it. We're just not opening it up to everybody. Like, for instance, if you work for a company who probably should be a member of the OFA and they just haven't done it, then we'll ask that you get your company to at least become the lowest level member and get your account that way. So once you get an account, which is a pretty simple, easy process, usually turnaround within a few hours. You have to set up your client for access. It's all via OpenVPN and Secure Shell. Then we would hope that you would join the FSDP working group mailing list. We are going to have more communications on that mailing list in the future than we do now, because right now we're still setting things up. In the future, the operations of the FSDP are going to be, operational emails are going to go to that mailing list. And then once you get set up and get your account created and everything else, you should be able to do all of these things that are listed on this slide. I am going to be clear right now, we're still in phase 1 of the construction of the FSDP cluster. So next slide, please. Next slide. Here we go. Phase 1. We're just still doing the cluster build. The cluster is not yet what I would call functional. You can check out machines, you can log in, you can see that they're up and running. But where we haven't got everything configured yet is it may have multiple RDMA interfaces in them, but the switches may not be all configured yet, so you may not be able to actually communicate with another machine over the RDMA fabric versus the lab fabric. And in some cases, we're still waiting on one final switch. I don't think we have it yet. So there's still stuff being done, and we haven't got it to the point where it's at phase 2. Phase 2 is where things are really going to become interesting, where I would strongly encourage people, get your accounts, get set up, and start running. You can join now in phase 1. You're going to have a little bit of a wait until we get everything running. Phase 2, if you join then, I would expect you to be up and running immediately. So that's kind of where we are on all of that stuff, and this is our time limit, so I'm going to open it up for questions if anybody has any more. I don't see any questions.
Yep, I don't see any either.